Revisions for wear-associated component loosening and for recurrent dislocation of the hip are the two most common reasons for revision total hip arthroplasty, accounting for nearly 55% of all revisions. The direct costs of these revisions exceeded $500 million in the United States Medicare population alone in 2006, and these patients represent only about half of the revision total hip population in the United States. Cup malposition is the single greatest factor associated with both revision for wear and revision for dislocation. Many studies demonstrate that the majority of acetabular components implanted using traditional methods are grossly malpositioned. A study published in January of 2011 from the Massachusetts General Hospital showed that half of all cups implanted there were malpositioned. Their newer study that hasn't yet been published shows that the incidence is even higher in community hospitals. Similarly, Saxler showed a cup malpositioning rate of 74% and DeGioia 78%. And the problem is getting worse. The advent of larger bearings has exacerbated things because intraoperative assessment can show a stable hip with an even more grossly malpositioned cup. This leads not only to higher wear rates, but also to metal hypersensitivity and pseudotumor in metal-metal bearings, and to polyethylene fracture in metal on polyethylene bearings. The trend towards smaller exposures has made the problem worse as well. For example, the Callanan study demonstrated that 80% of hips performed using a minimally invasive technique were malpositioned. What about possible solutions to this problem? Since the position of the pelvis during surgery is highly variable and unknown, measurements based on intraoperative radiographs are not only inaccurate but potentially dangerously misleading. Even instant intraoperative digital radiographs where the angle of the X-ray can be adjusted are of limited benefit because you cannot quantify the tilt of the pelvis on these images, and errors around the pelvic tilt axis, otherwise known as the medial-lateral axis, are often the greatest errors. What about doing an anterior exposure in the supine position? While the greatest cup inaccuracy rate in the Callanan study, which was an 80% malposition rate, were in the hips where the cup was placed through an anterior exposure in the supine position and with the use of X-ray. What about custom templates for the hip? We've seen that these can work for the knee, but even though they don't exist yet for the hip, given the relatively limited access to the acetabulum compared to the distal femur and proximal tibia during knee arthroplasty, we can easily anticipate that this method will prove to be inflexible, clumsy, expensive, and useful for only one operation. What about computer-assisted surgery? Well, even though this problem can be largely solved using this technology, after a decade of availability, computer-assisted surgery is not commonly used. This is likely because it is too expensive, too complex, and too time-consuming. Another suggestion has been the application of robotics, but compared to conventional computer-assisted surgery, robotics is even more expensive, even more time-consuming, and even more complex. The HipSextant is a mechanical navigation device cleared by the FDA for patient-specific navigation of any acetabular component that performs pelvic registration, pelvic tracking, and cup orientation tracking in a single device. The planning is based on a low-cost, low-dose CT study performed on the day of the preoperative visit. A three-dimensional model is then created and the standard pelvic coordinate system is established. Next, the patient-specific coordinate system of the instrument is then determined by 3 points. The first point, called the base point, is located behind the posterior rim and 20 millimeters above the infracotyloid groove. The second point, the crest point, is located on the lateral side of the anterior superior iliac spine. The third of the 3 points needed to define the patient-specific coordinate system of the instrument is the landing point. This point is unique in that it is equidistant from the other 2 points and located on the surface of the bone. With these 3 points, the three-dimensional relationship between the pelvic coordinate system and the instrument docking coordinate system for that individual patient is now known. The surgeon then defines the desired goal of cup orientation in the clinical coordinate system, and the angles on the orthogonal protractors on the top of the HipSextant are calculated so that the direction indicator points in the direction of desired cup orientation. Knowledge about supine and/or standing pelvic tilt can be incorporated into the plan as well. Intraoperatively, once the cup is prepared, a calibrated drill guide is used to place a pin to mark the base point location. After the cup is placed into the incision, the HipSextant is slid over the base point guide pin until it touches the bone. The superior spine trocar is then percutaneously docked. The location can be probed with the trocar to ensure proper placement. The landing point trocar is then inserted percutaneously to dock the instrument, thereby registering and tracking the pelvis in space. The cup is then inserted with the cup insertion handle aligned parallel in 3 dimensions to the direction indicator, controlling both inclination and antiversion. A parallel guide can be used to fine-tune the accuracy of parallel alignment. Although a specialized cup impactor is shown here, the device can be used with any cup impactor. 70 total hip arthroplasties performed using the mechanical navigation device were compared to a control group of 146 total hip arthroplasties performed using CT-based computer-assisted cup placement using optical tracking. Accuracy was measured using a validated 2D, 3D matching method that uses the preoperative CT to determine and to account for the orientation of the postoperative radiograph. The manual instrument was statistically significantly better than the control group for both inclination and antiversion. Incision to dressing time was 20 minutes faster for the mechanical navigation group, which was also statistically significant. Cup malpositioning is a universal problem in total hip arthroplasty and hip resurfacing, which may be becoming even more common with the use of large bearings and less invasive techniques. Fast and simple methods of placing the cup accurately are needed. The use of a universally adjustable, reusable, patient-specific manual navigation instrument represents one solution to this problem.